Section 3.4 is on using slope to graph linear equations. As we can see in this table here, the steps for using slope and the y-intercept to graph a line are to first plot the y-intercept, then starting at that point, count rise and run to find another point. So I'm going to start at the y-intercept for the first line here, 0, -3, and draw my ordered pair. I'm going to use my slope. My slope is 2/5, and remember that slope is always rise over run. So the slope of 2/5 means from the point I already have, I'm going to rise 2 and run 5. So rising 2 will put us up at -1, and run 5 will put us over to 5. So we'll draw that point. I can also do this in the other direction because 2/5 is the same thing as -2 over -5. Two negatives will make a positive, right? So -2 over -5 is the same thing as 2/5. So instead of going up 2, I can go down 2. Instead of going forward 5, I can go back 5. And you can see that all three of these points that we create by using the slope are going to be on the same line. To finish the line, we're just going to connect these points. So if I have a slope and one point, like the y-intercept, it's very convenient to create any number of points quickly to be able to draw the equation of a line. Let's look at the next one. We're going to start at the y-intercept, 0, 4. And we're going to count using that slope. The slope is -3/2, which can be either counted with the 3 being negative or the 2 being negative. Each of these situations has one negative, so the entire fraction would be negative. So if it's -3 over 2, then we'll go down 3 for the rise and over 2 for the run. Let's continue. Down 3 again, over 2, and down 3 one more time, over 2. We can quickly get a set of points that are going to fit on this graph. Let's connect them. Now if you notice, if I would have done the reverse, up 3, back 2, I would get the same set of points. Up 3, back 2, 1, 2, 3, it's off the graph. Back 2 would put me about right here. Now if I start at one of the lower points and go up 3 and back 2, you can see it's going to land up 3, back 2 on each of those points. So it doesn't matter in which direction I go, but because of where the 4 was, it made more sense for us to go down and over so we could fit our points on the grid. Let's look at a couple more examples. The next one is going to have a y-intercept at 0, -1. So we'll draw that point first. And the slope is -2. A slope of -2 could be -2 over 1 or 2 over -1. Since each fraction contains only one negative, it's equivalent to the slope -2. In the first slope, -2 over 1 will go down 2 over 1, down 2 over 1. That's as far as we can get and still be on the graph. We can get more points in the opposite direction by going up 2, back 1. So up 2, back 1, up 2 more, back 1, up 2 more, back 1, and so on. We're going to run out of space in the graph. Let's connect these. For part D, we're going to need to remember what it means for the slope to be undefined. The slope meaning undefined is the same thing as there being no slope at all. And if there's no slope at all, this line must be a vertical line. So we read and interpret that slope of undefined or no slope as being vertical. We go ahead and draw our ordered pair. Our y-intercept is 0, 2. And it's going to be a vertical line that goes through this intercept. So it's going to be vertical. It's going to have to just go right straight through the y-axis. Let's go ahead and draw that line in. So the vertical line going through the point 0, 2 will actually be the line that is the y-axis. In example 2, we want to create a table of points and use it to graph the equation y equals 2x plus 1. So we're going to start our table by picking a couple negative x values and a couple positive x values. If I choose -2 for x, the y value will be 2 times -2 is -4 plus 1 is -3. So I can graph the ordered pair -2, -3. If I choose -1 for x, the y value is going to be -2 times -1 is -2. Plus 1 is -1. So we can graph the ordered pair -1, -1. If I choose 0 for x, 2 times 0 is 0, plus 1 is 1. So we'll have the ordered pair 0, 1. And if we choose the x value 1, the y value will be 2 times 1 is 2, plus 1 is 3. So we have the ordered pair 1, 3. And finally, for choosing 2 for x, 2 times 2 is 4, plus 1 is 5. So we have the ordered pair 2, 5. Let's connect these to graph the equation. What is the slope of this graph? So if we recall, if the equation is in the form y equals mx plus b, the form where y is solved for, then we have a coefficient of x and a constant. The slope of the line is m, and the y-intercept of the line is 0, b. So the slope, or m, value is 2 for this line, and the y-intercept is 0, b, where b is 1. Because an equation in this form will tell us directly the slope and the intercept if we look at those two values, this equation is called slope-intercept form. So if I look at the equation y equals negative 3x plus 8, without graphing I can tell you the slope and the y-intercept of this equation. The slope, or m value, is negative 3, and the b value is 8. That is not the y-intercept, but it tells us that the y-intercept is 0, 8. The 8 itself is just one piece of the y-intercept. The other part is always the 0, since an intercept will always have a 0 in the opposite coordinate. For a y-intercept, there will always be a 0 in the x-coordinate. Next, we want to sketch each equation using the slope and intercept. If the equation is y equals 3/5 x minus 1, the slope is the coefficient of x, it is 3/5. And the y-intercept is going to be 0, negative 1. To graph this line, we start by graphing the y-intercept at 0, negative 1, and then counting rise over run for slope. The slope is 3/5, so we'll go up 3 and over 5. That's the same thing as going down 3 and back 5. The unsimplified version of that slope will get us another ordered pair. And we'll connect all of our ordered pairs to graph the line. In the next example, y equals negative 4/3 x plus 5. The slope is negative 4/3, and the y-intercept is 0, 5. So when we graph this, we start by plotting 0, 5, and then we use our slope to count down 4 and over 3 for rise over run. So if we do that once, we get 1 point. We can go down 4 and over 3 again for the next point. And we connect them for our final graph. Let's look at a few more. If the equation is y equals 3x minus 4, the slope is 3 and the y-intercept is 0, negative 4. So I'm going to start graphing this by drawing 0, negative 4, and counting that slope. Remember that if the slope is 3, that's the same as 3 over 1. We want to know what our rise and our run are. So our rise is 3, up 3, and over 1. Do it again, up 3, over 1, up 3, over 1. And we connect those dots to form the line. In part D, y equals negative 2x minus 3. The slope is negative 2, and the y-intercept is 0, negative 3. To graph this, we start with the y-intercept at 0, negative 3, and we use our slope again. The slope is negative 2, which is the same as negative 2 over 1. So it would be from the point we start at, down 2 over 1. I'm going to run out of space here, so we also want to use the opposite of negative 2 over 1, which would be 2 over negative 1. If you divide these, you still get the original slope of negative 2. These are equivalent fractions. This one's going to say you can do the same thing by going up 2 and back 1. You'll have the same slope, up 2 and back 1. And connect to form your line. Alright, in example 5, we're going to determine the signs, whether they're positive or negative, of the constants m and b for the following graphs. So in this graph right here, we want to determine if m and b are positive or negative. Remembering that m is the slope and b is the y-coordinate of the y-intercept. So m is, since this line is going down, it's going to have a negative slope, it's decreasing. M is negative because the line is decreasing. Now the y-intercept is 0, b, so b, the y-coordinate of the y-intercept, is negative because it is a number below 0 on y. Positive values of y are up here, negative values of y are below the x-axis. So b is negative, it's below the x-axis. We can use our knowledge about m and b to write the equation of a line if we know its slope and its y-intercept. The equation of the line can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. So to write an equation of a line whose slope is 3, we'll start with y equals 3x, and the y-intercept is going to be 0, negative 6, which means that negative 6 is the b value, so negative 6. So an equation with slope 3 and y-intercept 0, negative 6 is y equals 3x minus 6. In part B, this equation would be y equals, the slope is negative 2/3, x, the intercept is 0, 5, so we'll have plus 5 at the end. For the next example, we're going to write the equation from a picture. So if I look at this graph, I can identify what the y-intercept and the slope are just from this graph. The y-intercept, this point right here, is 0, 3, which means that our b value is 3. And I can count the slope by counting what the fall and run are, the rise and run, rise being negative, to get between these 2 points. That's the same distance it would take to get between these 2 points or these 2 points. It doesn't matter which 2 points I choose, I just need to count the distance to find the slope. I've got a -6 rise with a run of 7. So my slope is -6/7. My m value is -6/7. Therefore, the equation of this line is y equals -6/7 x plus 3. We can also graph lines in a calculator. To graph lines in a calculator, we're going to use the y equals button. On a graphing calculator, the y equals button is up here near the screen. If I go into that menu, I can type up to 9 different lines. We're just going to start with one line. Let's go ahead and use the equation we just made. The equation was -6/7, just use the division bar for the fraction, -6/7 x plus 3. Then we'll go over here and hit the graph button. And as a line draws, we can compare it with the one that we saw before and notice that they are the same. There are separate videos about the calculator if you want to go to Alana Tuckey's channel or follow that link. Let's look at example 8. Let A be the amount of money in billions of dollars that U.S. residents have sent to Mexico in the year that is 2 years since 2001. A reasonable model for the situation can be given by the equation A equals 2.5t plus 7. Note that the equation is in slope-intercept form. A could be replaced with y and t could be replaced with x. So we know that these values, 2.5 and 7, correspond with the slope and y-intercept of the graph. Before we can start graphing this equation, we need to label our axes and make an appropriate scale. I chose a scale where the t values increase by 1 and the a values increase by 5, partially because I see that I need to get to at least 30 on the a scale. And when I begin graphing my line, I'm going to start with an intercept of 7. 0, 7 is about right there. And because my scaling is larger than 2.5, I'm going to want to maybe get a table here to help me out with this. In my table, my first ordered pair is 0, 7, the y-intercept. I know that if I use a 1 for a t value, I'm going to increase by 2.5. 7 plus 2.5 is 9.5. If I increase one more to 2, I add another 2.5. This will put us at 12. And for a 3 value of t, we'll add one more 2.5. This will put us at 14.5. Let's graph these ordered pairs to help us graph this equation. You can grab a few more ordered pairs if it's going to help you graph. I've only got 4 right here, which as you can see, going all the way across the graph, these are all so centrally located that we might have lost some accuracy over here. So let's check ourselves by plugging in one of the larger values, like 13, and see how close we got with that line. If you plug in 13, you'll take 2.5 times 13 plus 7. That gives you 39.5. It shows that our graph should be up a little bit higher, so I'm going to have to go ahead and move that. Okay, it just means that I wasn't accurate enough with only a couple of points on such a large grid. We can do one more to check ourselves. Let's try 10. If I plug in 10, 10 times 2.5 is 25, plus 7 is 32. So we should have 10, 32, and that does look like about what we have, 10, 32. So it's important to note that when you're graphing something, you should try to spread your ordered pairs out to have representatives covering a larger portion of the grid to be able to maintain accuracy, especially if you have a scale that is not just by 1 on one of your axes. Now we want to use this graph to predict in which year the U.S. residents will send $30 billion to Mexico. So it looks like our graph is going to intersect 30 billion about here, which will put us at about 9.1 or 2. Though we'll be in the year that is 9 years since 2001. So a t value of 9 will give us the year 2010. In 2010, U.S. residents will send $30 billion to Mexico. So we've talked about some of the challenges in graphing this by hand. Let's go ahead and graph it on our calculator to confirm our prediction. So my calculator, I'm going to go back to my y equals menu, clear out my previous graph, and type in the new one, 2.5. There's no way to use the t key. I'm going to use this variable key right here. So it's going to give me an x. My graph needs to be in terms of y and x. I can't use variables like a and t in the calculator, so I just need to understand the difference between the two. And plus 7 was the rest of the equation. Let's hit graph. Okay. So our graph is nowhere near steep enough. It's got a much different scaling. So we're going to go ahead and try to change the window to look a little bit more like the window that we graphed by hand. When I graphed by hand, I had a window that ranged from 0 to 20 or so on T, and 0 to, we'll say 50 or so on A. So I'm going to change the window using the window key. X, which is T, we're going to change from, say, 0 to 20, leave the scaling at 1, and we're going to change our Y from 0 to 50. Then we'll regraph. Our graph here looks a little bit more like the one that we had seen when we drew it by hand. Now, how do we tell where 30 is? It's going to be kind of a pain to figure out where 30 is all the way up here, so there's two ways to do this. We can look in the table. So table is highlighted in blue, so hit second first, then go to the graph menu. It'll bring up the table instead. And I can scroll down through my table. I'm looking for when the y value was about 30. So I can see that it's going to happen between years 9 and 10, like we saw on our graph, which would lead us to the conclusion that it would be in the 9th year since 2001, and 9 plus 2001 gives us 2010. Another way to get a good guess would be to add an additional y equation. With the y equation, simply the value we're trying to find, 30, and looking at the graph. So it tells us where 30 is, and it's kind of just tracing 30 out, and we can see where it hits our other line. And if we trace down, we can count up to this value and find out that this is the value just after 9, so we can get that approximation of 9 again. It just gives us another way of finding what that approximate value is, using the table or graphing 30 so we can figure out easily which tick mark is 30. And that's the end of the section.